right, good afternoon, folks. Hope you guys are having a good time. Today is the third day, and I hope you guys like the sessions, over the past 2.5 days. So probably like this is the last session of the day. So, we'll keep it simple and short for you guys. So my name is Gaurav Anand. I'm a customer engineer at Google Cloud, based in Singapore, covering the Indonesia business. And with me, I have Wilson, who's flown all the way from Singapore, from Traveloka, so we would be kind of running through this session. So the way we're going to run this session is we'll have an initial part of an intro about the data analytics patterns, at Google Cloud, and Wilson would kind of share his journey and Traveloka's journey, implementing the data pipelines and some of the cool stuff with GCP and Traveloka. All right, so over the past 1 year, while I have been talking to a lot of analytical leaders, uh, you know, I've seen a lot of challenges, which kind of come up when it comes to big data. So the most, I would say there are three most important challenges which kind of comes up often are these. I mean, we all know the amount of data which pretty much all the enterprises are producing these days has grown enormously, and that continues to grow. So you need to have an infrastructure which scales linearly as you grow your business. You don't need to re-architect your architecture or your infrastructure, every 3 months, every 6 months. So you need that level of infrastructure which just scales automatically. Uh, the second one being finding the right talent. So the way the technology has evolved, if you see the open source technology, the way it was 10 years back, the way it is now, there has been an exponential growth in the set of technologies, and having your team kind of be competent across all those technologies is a challenge because every 3 months you see something new coming up. So that also is kind of one of the biggest challenges which most of the enterprises are facing. And last but not the least, cost. So as you grow, as you scale, your cost should not linearly increase with your scale. So there has to be some sort of cost control in place so that you don't have to kind of increase your infrastructure along with the cost. Now, as I just mentioned a while back, over the last 10 years, the open source ecosystem has grown exponentially. In fact, I still remember my days, 10 years back, when you search for Hadoop, the only link which you get in Google is the official Apache documentation and nothing else. And if you do that now, there are like tens and thousands of, links and documentations and whatnot. So the ecosystem around Hadoop, Spark, and other components continues to evolve, but that brings another challenge of having your team to kind of learn all of those technologies. Having said that, there is no single technology which kind of solves all the problems, but that doesn't mean you need to learn all the technologies. You need to kind of narrow it down to few which kind of covers most of your use cases. So pretty much in the room, most of you kind of belong from one of these industry verticals, and there isn't any industry vertical now which doesn't have a need for data analytics or even advanced analytics. You might see there are few use cases which are like pretty common across multiple industries, and the biggest focus is user. And what you're going to hear today from Wilson, from a Traveloka perspective, is how they improve the overall user experience. Because the end goal is that if you have a product, if you have a service, the end user should see what he wants to see and not what you want him to see. So at Google, we kind of try to make the entire data lifecycle simple. So we have tools and services across these 4 fundamental lines. The first one, of course, being the ingestion. So, there were days wherein people used to kind of keep batch ingesting a lot of data, like once in an hour. Your data available is once in a day, and then you have a lot of analytics and reporting running on top of it. But the way streaming analytics has grown over the past few years, it has become one of the most critical components of most of the businesses. So, so if you have to stream in just your data, you can use PubSub, which is our messaging bus at GCP. But if you come from Kafka or any other messaging background, you can kind of use that as well. From a data pipeline and processing perspective, we have Cloud Data Flow, on which you can run Apache Beam. I'm sure you might have kind of gone through some of the sessions in the last 2 days on Dataflow and Apache Beam. And if you're coming from the Hadoop or Spark background, you can run it on top of Cloud Data Proc. When it comes to building your data lake or building your data warehouse, you have two options, which is BigQuery and cloud storage. Again, choosing whether to have your data lake in BigQuery or cloud storage, there are some pros and cons on that as well. And of course, at the end is the advanced analytics. So once you kind of land your data in either in BigQuery or your cloud storage, you can run all of your advanced analytics, your machine learning, your reporting, and whatnot. So as I was saying, streaming analytics has gained a lot of importance over the past few years. So this is like one of the most common patterns which we see most of the customers using, wherein you have your devices, you have your applications, web, mobile, whatnot, and then you bring a messaging bus in between. You get to choose between PubSub, Kafka, or any other messaging bus, and then you use Apache Beam on top of Dataflow for transformation, or you use Spark or any other open source component on Dataproc. And then you have an option to land that data across multiple storage systems. So BigQuery, is the most popular choice when you have like analytics, you have a lot of dashboards, reporting on top of it. Bigtable, if you have to do a lot of time series analytics, Bigtable is very good at that. In fact, you would see one of the most exciting use cases at Traveloka and how they use Bigtable for that. And again, if you want a serverless machine learning service, you kind of run your models on CloudML. So with that, I would like to bring Wilson back to kind of share what they have been doing at Traveloka over the year and kind of talk through some of the use cases and the underlying technology. Okay.
So hi everyone, my name is Wilson. I am from Traveloka. So from you guys who is not aware of Traveloka, Traveloka is one of the online travel booking company in Southeast Asia. We started as an online travel booking agency, and actually we expanded to multiple businesses over the years. So what we're going to talk about today is basically, we're going to talk about how is data to Traveloka, how we use the data, how we solve our problem with data, and then what is our challenges on dealing with data in Traveloka. And we're going to also give you a brief walkthrough on how we adopt Google Cloud into our data ecosystem. And the last but not least, basically, we're going to share you one or two use cases that we encounter in Traveloka and how do we solve the problem with our approach. So the first thing that we're going to share with you is basically what is data to Traveloka. So Traveloka is a data-driven company. We actually use data for a lot of things. We collect data and we use that for making decisions at Traveloka. For example, for doing business analytics, and we also collect data and use them for machine learning. For example, for the recommendation system, optimization, fraud detection, and also maybe credit risk model. And this is some of our use cases for data, and there is much more use cases that how we use our data. And this is some of the example on how we use data. The first thing that I'm going to share with you is challenges in Traveloka on dealing with data. The obvious challenge in Traveloka is basically the size of the data itself. The size of the data is not that small. We're actually getting data at around few terabytes per day. So you cannot really solve the use cases by using traditional data technology. So another thing is basically Traveloka being a company that has multiple line of businesses. We actually has a diverse source of data. So maybe some company, they only have one line of business, let's say e-commerce or travel booking, flight booking. In Traveloka, we have a multiple line of businesses such as flight booking, accommodation, car rental, and so on. So we have a multiple number of teams that actually working together, and we as the data team in Traveloka, we need to actually gather data from all these various places into our single data warehouse. The another challenge for the data in Traveloka is basically there is a multiple team who want to use the data, not only our teams. And they have all their own use cases, and we need to able to cater their use cases as well. The next thing that we want to solve is basically the system residency. So everyone want to use the data, and they want the system to be reliable. They don't want the system to be like broken once in every week or once in every month. They want the system to be as reliable as possible. And last but not least is basically the cost needs to be as reasonable as possible. So looking at all these challenges that we want to solve, we actually come up with a few features that we want to achieve, which is we want to achieve as long as possible the latency of the data. So as soon as the event is happening, as soon as someone do something in our web page or in our mobile apps, we want that to be available as soon as possible to the BI dashboard or reporting or any other use case that we have. The next thing that we want to do is the high availability to cater the latency of the system itself. So the system need to be available, and because Traveloka is a data-driven company, we actually use data to make decisions in the company. So if the system is actually compromised and let's say the dashboard or the reporting is not available for a few hours or a few days, actually it's going to cost a lot for Traveloka. The next thing that we want to achieve is basically we want to spend time on operation as minimum as possible. We want our engineers to spend their time building something productive and creative rather than debugging application, looking through the logs and do other things that actually can be solved by other means. And this is our goal, and actually the next thing we're going to share you is actually the initial data architecture that we have in the past that is actually sitting entirely in Amazon Cloud. And this is briefly on how it looks like in the past. So, and basically we have data coming from the mobile apps or the web desktop. It will actually push data into Kafka directly, and then we have Goblin jobs that actually gonna ingest data in our databases and do ETL in Hive, Presto, or Spark, and gonna store all that in our S3 data lakes. And we are not only storing data from the tracking data, which is coming in real time in messaging bus, which is Kafka. We also getting data from databases like Postgres or MongoDB as well. So with this approach, we actually have a limitation on the data end-to-end latency, which is actually at most, the best that we can do for the data itself is basically an hour delay. So if something's happening with the app or the system itself, we can only get the data an hour after. So looking at this limitation, we actually try to seek a system that actually can solve our use cases for low end-to-end latency of the data. And that is how actually we try to Google Cloud at the first time. Our first use case is to do stream analytics with our data. So we try to double our data into Kafka and PubSub directly. And we build our streaming jobs in Cloud Data Flow and push data directly into the BigQuery itself. And this BigQuery is gonna be read directly by the BI tools and the reporting tools that we have. So by doing this approach, we actually already see a number of advantages that we cannot see in the previous architecture. The first and the most obvious thing is the latency of the data itself. As soon as the event comes, it goes to PubSub, Dataflow, and BigQuery. It goes into BigQuery in a few seconds latency. So if something is happening with the data, let's say you are doing A/B testing, you are doing a campaign, you can actually query data directly as soon as the event is happening. And the next thing that we see from here that is basically the PubSub, Dataflow, and BigQuery is the first technology that we try. Is actually all of them is serverless. So you don't need to actually worry about installing dependencies, installing library, not provisioning, and other thing that you used to do when you are using traditional technology. The second thing that you can notice is basically Dataflow has built-in scaling feature. So you don't need to actually hard code your your machine requirement for your streaming jobs. You can actually set the auto-scaling feature on, and then your streaming job will scale up and down based on the traffic that comes. And it actually really reduce the amount of operations that we need to do with our jobs. And the performance of BigQuery itself is actually a lot better compared to our SQL engine that we used before, which is actually we use Hive and Presto before. So looking at these advantages that we can already see, we actually decided to broaden our adoption of Google Cloud into our data ecosystem. And that is how we get to the next stage of the data infrastructure, which will look like a number technology in Google Cloud. And this is how it really looks like in high level. So data actually will come directly from the apps to our endpoint that we built in Kubernetes. And it actually puts data directly into PubSub, goes into data flow, same as before, stream into BigQuery. And we actually also do another data flow jobs that we're going to convert data in BigQuery to a Parquet format in GCS. And we also store other metrics in our data in Bigtable, which I'm going to talk more in details later. And all of this, actually, the orchestration is done through Airflow. And the good thing about all of this, if you are aware, actually, is all of this actually already have ability monitoring and logging through the Stackdriver. So you don't need to worry about your logging library or your metrics library, such as SLF4j, Log4j, and something like that. And we also didn't deploy anything on the bare VM anymore. All of this actually is either a service offered by Google or is deployed on the container in Kubernetes. So, and the other thing here is that doesn't have auto scaling is basically a Bigtable. And the other components like Kubernetes, BigQuery, Dataflow, PubSub, all of them actually can scale by the demand. So you don't need to worry about how to scale your traffic through the peak period such as end of the year, long holiday, and so on. And after we get our data into central BigQuery data warehouse, we actually build our data marts for sub-teams in Traveloka to use. So from a single project data warehouse in BigQuery, we actually built a number of BigQuery projects as well, sitting in a different project in Google Cloud. Why actually we're going to do that is basically we want the permission of the data marts that we have to be as granular as possible. For example, let's say I am from marketing, so I have data of my ads, ROI, as revenue, and so on. And I don't want this data to be shared along the company. So I can actually choose the data to be private to my team, and I can share the data that I want to share with the other team in Traveloka. So we actually have one project for BigQuery for each team in Traveloka, so they can independent to choose what data they want to share with the company and what data that they want to keep private in their team. And another thing is basically why we have data in BigQuery and GCS, the same data. The thing is basically when we are doing ETL from the data warehouse to the data marts, we are doing ETL with a number of ways, which is most of it is by doing BigQuery SQL directly for a simple transformation like filter, join, and grouping. And other more complex ETL, we need to use Dataflow or Spark, for example, for machine learning and so on. And if you are doing data processing with Spark, actually, Spark can read directly from BigQuery, but the efficiency for reading data in BigQuery compared to reading data in Parquet is still unmatchable. So Spark reading data from Parquet is still much more faster compared to reading data in BigQuery for now, actually. And all of this data mart in BigQuery is going to be read directly by our BI tools. So every analyst in the team, they can actually make their own dashboard, and from the data mart, they can actually directly query the data from the BigQuery to their BI dashboard and make dashboard for the business stakeholder to see. And this is basically the high-level thing that we want to share with you with the data architecture. The next thing that we're going to share with you is basically one of the use case of the data platform in Traveloka on what we call it the customer data platform. Oh, sorry, this is the metrics in Traveloka that we want to share with you, some of the metrics. For example, like number of data that we get every day, a few terabytes per day, and then a number of batch job that we do every day, 60,000 plus, a number of charts that is generated from the BigQuery. And most of these charts using BigQuery, right, actually is coming on a near real-time basis. So as soon as the event is coming, as soon as booking happening, you can actually see the charts updated at real time. And the next thing is basically the customer data platform. It's one of the use cases that we want to share with you on how we deal with analytics in Traveloka. This is one of the example question that the business stakeholder or other teams asking to our team. For example, when did this specific customer buying from us the first time? What is this guy last purchase from us, and so on. And if you see this kind of questions, you can actually answer this question easily using BigQuery. You have all the data in your BigQuery. You just query your data, you do your select star from this table filtered by the user ID, and you get your answer. But the problem is basically BigQuery can only do a partitioning by date. And that is one of the downside of BigQuery. And if you're doing this kind of questions, you don't know the day or timestamp of the purchases. So you need to scan all the time range to filter for this customer and see when is the first purchase of this customer. So you will actually incur a lot of unnecessary scans of the data. And another thing is basically BigQuery is designed to be an analytical data warehouse. So it's designed to do analytical scan, and the response time is supposed to be a few seconds or maybe a minute for huge joins. For some use cases, we need this to be answered in milliseconds, because this is not going to be called by people. This is going to be called by machine. We expose an API so that other people actually can call the API and get the answer directly. For examples, and this is how we actually solve our use cases. We actually push our data not only in BigQuery, but also put our data in Bigtable as well. So we develop our API in Kubernetes and expose it to our teams in Traveloka. So for example, for flight teams, hotels team, accommodation, they can call our API, and our API will actually query Bigtable or BigQuery to get the answers for them. And why actually we use Bigtable for our use cases is we have a few reasons. The first thing is basically we want the app capability to have a range scans. This is actually one of the reasons why we cannot use something like Apache Cassandra. It actually can, as far as I know, it can only do a simple key value fetching, while we actually need much more capability than that. The other thing is actually we need to be able to cater dynamic columns, and it's possible we want it to be a managed service, which is Bigtable can offer to us. And it's also familiar with the HBase API, which is open source Java API from Apache HBase. And many people are already familiar with that kind of API. So we're going to show you about example data modeling in Bigtable that we do to answer that kind of questions. For example, this is one of tables in our Bigtable, and we want to answer when this specific customer buy from us the first time. So we actually store the data in this kind of data modeling. We actually use the user ID as the prefix, and we append that with the timestamp of the event. So the event can be for example, for this kind of table, the event is purchase, and the value is basically the detail of the purchase, whether he buy a flight ticket from us or a hotel voucher or anything. And BigQuery is similar like Bigtable. They store the data in a sorted manner. They do not hash the key to store the data, unlike if you compare it with Apache Cassandra. So you're gonna get your data stored something similar like this. In this case, we have 3 user ID, A, B, and C, and the number behind is the timestamp of the event. So your data will be stored like this in this exact order. It will be the user ID, the timestamp, and the purchase. So if you have a data model like this and you have a question on, I want to know like when is this guy buy from us the first time. So what we can do is basically we cannot do a simple key value fetching because we don't know the timestamp. What we can do is basically we can define a range scans for the table. We can define the range scan to be the user ID. So because we know the user ID, but we don't know timestamp, so we just put 0 as a timestamp, for example. And when you're doing range scans, we'll fetch the first row, which just has the minimum timestamp. And you got your answer directly, which is the first timestamp that this customer buy something from us. Another similar problem is basically, when is the last time a specific customer buy from us? If you have this kind of same data model, you can, with HBase, you can do a reverse scan from the bottom, specify your user ID, and you get the answer directly. You get the last timestamp. But Bigtable actually cannot do that. While Bigtable actually compatible with HBase API, there is some small things that Bigtable cannot support. One of them is the reverse scan. So we need to actually do a small workaround to be able to answer these questions. And this is how we solve this kind of problem. So we alter the key. Instead of using the user ID and the actual timestamp, we actually use the user ID and the timestamp. We change it with the maximum timestamp minus the timestamp itself. If you do that way for all your keys, you're gonna end up with your data but sorted in a descending order. The first row will be the last purchase, the last row will be the first purchase. And if you already have this kind of data model, you can actually do the same approach that last time. You do a range scans, specify your ID, and you get your first row as the last purchase of the people and its details. And this is one of the example data models we do in Bigtable, and we got a few more use cases that we do with Bigtable, but we're not gonna share it today. And the next thing that we're gonna share with Traveloka use cases is about the data quality and anomaly framework that we did in Traveloka. So what is the data quality itself? Why do we need data quality? In Traveloka, like I mentioned before, Traveloka is a company with a multiple line of businesses. So the data itself actually is coming not only from one sources, it's coming from multiple sources and multiple teams. So data, if everything is going smooth, data is coming direct to us in correct data. But if something's happening, let's say someone actually deploy a new version, someone refactoring an app and so on, and they forgot to put the code and for the tracking, and the data stops coming, or the data coming but it's all null and so on. And all of this actually can cause many problems. For example, your downstream process can actually fail at all. You cannot see your reports, you can see your dashboard, or it's still success, but your reports will be, the number will be obviously wrong. And the most dangerous one is basically you don't know that the error is happening. You trust your dashboard, you believe the number is correct, but actually it's wrong. And actually you are using the wrong data to make decisions. And how do we solve this problem? Actually, because we have all our data in BigQuery, all of them is mostly structured data. There are tables and they have columns, and each column have their own data type. For example, for this table, we have a few columns. For example, we have a string column and integer column. And each of the columns itself, it has its own metrics. For example, the string column, we can actually know what is the proportion of null value of this column, what is the distinct value of this column, and other metrics as well. If you actually collect all these metrics for each of the columns, and you collect it over the time, you will end up with a number of time series for a table. So for one table, you can gather a number of metrics. The obvious thing is number of rows of tables. The next thing is basically each of the columns, it has its own matrix. For example, the string column, for example, like the country, you have the number of distinct country, you have actually number of null countries and so on. So if you already have all these metrics from your tables, you actually refer to this matrix to determine whether your table is correct or not, for example. So when you have this kind of matrix, you can actually detect whether, let's say, your data is stopped coming at all. You're going to notice the number of rows actually is dropping. Or let's say someone is refactoring your mobile apps and it forgot to put some code in the country. So all your country will become null. Or let's say in normal days, you have 10 countries coming to the data. You have Singapore, Indonesia, Malaysia, and so on. And then suddenly one day you only have 2 countries. And you know something is happening. And maybe number is wrong and some other thing is going on. So by having all this metadata of your data, you can actually analyze your time series of your table and determine whether your data is wrong. And this is actually how we built our approach to solve this. We actually have, this is the same BigQuery that we used before. It contains all the data, raw data. And we leverage the performance of the BigQuery to gather the data metrics from BigQuery itself. So we don't need to actually spin up another cluster, let's say another Spark cluster, another Presto cluster to actually do the heavy lifting for us. We do gather all the query using the BigQuery SQL directly, store it in the big table, and use it for the time series analysis. And after you have the time series, you can actually do your anomaly detection on the time series using similar approach, using view approach. For example, you can actually do a simple static analysis, user mean standard deviation, or you can use a library from Facebook like Propet. Actually, it's a time series analysis in Python from Propet, from Facebook, and some other library that you can use. By using like this kind of library and analysis, you can actually analyze whether your specific table or specific column in your table are behaving wrongly. While actually this is not going to cover all the use cases, it's actually going to cover most of the use cases that we encounter, and it's actually helping us a lot. The impact that we can already see is basically we can see the data is wrong as soon as possible. Previously, actually, if data is wrong, we don't know what is happening. We know the data is wrong from the stakeholder. Stakeholder, they see the dashboard, they see the BI tools, they see the emails, they see number is obviously wrong, or the number is not showing at all. And they tell our team, hey, can you check something with your system if something is happening? So by implementing this kind of system, we actually know the data is wrong as soon as possible, and we can actually inform the downstream user of the data whether we have a data problem or it's a false alarm or something else is happening. And it's gonna make your trustworthiness for your team because people can actually trust the reports that coming from your team rather than the previous one. They can get the reports, but they do not trust whether this number is correct or not. So this is one of the use cases that we encounter in Traveloka. And the next thing that we're going to share is the lesson learned when we implemented all these things. The first thing is BigQuery have a great performance, especially if you're doing SQL analysis with your data. For most use cases, especially for most BI use cases, actually you can solve within using SQL, mostly using group by, join, filter, and so on. And for the auto-scaling feature in Dataflow and other components such as PubSub, BigQuery, Kubernetes, is really useful to us. You don't need to worry about your peak period, your end of the year. You need to scale up your VM, and so on. It's all in the past. And all of these stacks in Google Cloud, like PubSub, Kubernetes, and the technology itself, they have all the built-in monitoring through the stack driver. So you have all your metrics flowing in automatically. You don't need to worry about implementing your own motor system or your logging using Log4j, push that into some other system. All of them is gonna be available for you directly, so you can actually do a debugging. Let's say if something is happening to your application, you can monitor your CPU, disk, your query in BigQuery, if something is running slow, and something else. And I think this is more or less the whole thing that I want to share with you today. And I'm gonna give it back to Gaurav. Thanks.
Okay.